Okay, well, thank you everyone for joining us this morning, this afternoon, or this evening for our 7 spatial database tips. And we hope that you're going to get some great little tips from us while we work through these. We're going to walk through an intro, and then we're going to be talking. Robin's going to take over and do some Oracle. And, oh yeah, we also need to introduce ourselves. Thank you, Robin. This is Robin Rennie.
And this is Steve McCabe.
Thank you. And we're both with the Professional Services Manager, Professional Services team here with Safe Software. And a lot of the cases that come in that are related to databases, Robin and I are the ones that are usually taking those ones. So you'll quite often be working with us on those. We're going to be working with show a number of techniques working with databases that you may not have run across in your daily work with FME. Just to kind of show you a few little tips and tricks and add a little variety to what we're doing there. We're working with 3 major non-Esri database formats. So as you see on the agenda here, Oracle, SQL Server, and then we'll do some PostGIS towards the end. Yeah, so we'll be doing some demonstrations with each of these formats as we walk through it.
Okay, so throughout the session, we'd love to have you add questions through the question pane.
Yeah, so we've got Mark Stokes and Ryan and Ken helping us. Ken's over in Europe in beautiful France. Ryan's here in the office, so is Mark. Mark's our Professional Services Manager, and Ken and Ryan are support product specialists.
Yeah, Ken's also one of our database gurus, so when he takes the overnight questions for us, which we really like.
Yeah, so they're going to be busy taking your questions, so if any questions pop up, it doesn't matter what it is. It may not even be related to your database questions or the webinar we're doing today. Pop it in there. If we can't answer it, we'll get back to you after the webinar is ended.
Also, if we don't get back to you, that's right, we'll follow up with you. And also, this session is being recorded, and it'll be the workspace and the slides and the video and all that will be up on the website.
Yeah.
Or you'll get it through an email, so you do get access to all of this.
Yeah. So Robin and I have to be very careful what we say here too.
Yeah, that's right, because it's going down into history forever and ever.
Yes. Okay, so first off, we're going to try to interact with you guys out there in the audience. We'd like to ask our first poll question. How long have you been using FME? And so for us, I know myself, I've been with SAFE for about 3.5 years now.
Yeah.
So that's pretty much my window. What about you?
And I've been here for about 8.5, so I've only been using the FME for about that long. So, yeah, between us, we've got a fair bit of experience here, I would say.
Yeah.
Although, admittedly, we don't use it so much as solve sort of users' problems with it. So it's always rather interesting when we have to put together a webinar and we run into all these issues, and it's kind of like,
that's right.
That's just the way it is. So.
All right, so we got a very even spread, very interesting. So we got people who've been here for less than a year. And people that had never used it as well.
That's good.
And then all the way across. So
for those of you that aren't familiar with FME and Safe Software, we are we'll just do one slide on who we are, and because we don't want to spend too long on this stuff.
Yeah, that's right. So yeah, we're FME Safe Software. We make FME Desktop and FME Server product. We're one of the leading spatial translation tools. I'd say we are. And we're also working with over 350 different formats of data to help you move your data around your enterprise. We can help quite a bit with that. So we connect the data, we transform it, and then we allow some automation that can go on in there. So that's a little bit about us. And now the next slide we're looking at is a couple links that will take you out to the web where you can get some great resources on our product, FME. And we do weekly live product demos. You can sign up; they're free. And as well, there's multiple online courses that we're doing, tutorials, etc., that will assist you in getting started with the product. There's more advanced technical webinars. This one here today. So stay with us. We'll hopefully show you some stuff that you're really interested and keen on kind of learning more about. But by all means, don't be frustrated. It is a pretty technical webinar we're doing today here.
So no sort of beginner concepts. Stephanie, I think, is also going to chat out a link to a Databases tutorial, which is a really good resource for anyone who's going to be working with databases. And that, although it's written in a slightly older version of FME, the concepts are all the same, and so some of the screenshots might be a bit different. But that's another great place to get going when you're getting started with working with databases in particular. So then we, just to make sure you're all still awake, we have another poll asking sort of what are the things that you typically run into when you're working with your various database formats. And so
yeah, so Stephanie's going to share that poll question. She's got it up there now, so just answer away. You know, for us here at Support, we see a lot of different things obviously creeping up from our customer user base. Anything from struggling to keep up with the changes and change detection, working with fixed data models, importing from different sources. What are some of the things you see?
That's right. So that's the sort of stuff we've sort of basically based our talk around, is some of the things that we know people might be running into. And of course, feel free to add anything to the questions pane if there's something that is driving you crazy or you have a question about. So that's the kind of information that we were looking for. Partly also it helps to decide where we're going to go, put some energy in the product, you know, to make some of these capabilities a little bit easier.
A little easier to work with, yeah.
So that gives us a good spread on what kind of things people might be looking for.
Interesting, yeah. So like,
and again, because it was a multiple choice question,
yep,
it doesn't add up to 100.
So that's fine. Half the audience really is interested in just about everything we want to talk about today.
Exactly. So hopefully everybody will learn something out of this. So frustrated. Everybody in life gets frustrated, and so we have put together a series of, they're pretty much unrelated little links, but we decided what we'd do was play through a kind of scenario that some of you may have run into, where perhaps we decided we'd work for the BC government, and
yes,
we wanted to collect data from all the municipalities in the province. And so they're going to send us a file geodatabase, and we want to be able to put this into a staging database, and we're going to show you how to do that into various database formats, and then explain how you might be able to look at that data from a couple of the other third-party products too.
Yeah. And
then we're going to work on refining it a bit as we move it into production. So we think we'll come up with something that'll work, but of course we have to have it done by tomorrow afternoon.
Yeah, that's right. So it's always done yesterday.
That's right. Pretty typical sort of stuff. Okay, so let's
so what do we got here, Rob? And this is our
move into the demos.
Diving into our first demo here. Okay.
So I was going to show you an example of how you could dynamically load data into a particular database format. So I was going to start up my FME workbench here. And as I said, no beginner tips here, so we're just going to go straight into generate a workspace. And as I said, we've been given this geodatabase that we want to work with. And I'll go and pick it up. And something that many of you may not have ever played with is this whole concept of using dynamic workspaces. So mostly when we create the workspace, we give it the source format, we give it our destination format, and we fill in the boxes. We tell it where we're going to put it. Most of you will probably be able to guess what that password is.
Yeah.
And then we leave it that way and use this static schema option. But today I'm going to show you what happens when you use this dynamic schema, and then we're going to play along a little bit more with that in the next demo as well.
And you can imagine both the source data here on the reader has a lot of different feature types in there, as well as the database that we're going to potentially either we're creating brand new tables or we could be writing to existing tables.
That's right. And so here we might not know what's in that geodatabase. It's just been sent to us, and we want to extract the data out of it. And we might not even have ArcMap installed, so that we can't look at what that geodatabase looks like, possibly. So there are actually ways of being able to read geodatabase without having ArcMap installed.
Yeah, that's right.
We've got a reader that does that now.
That's right. Yeah. You just need to have FME, and away you go. You can use the data inspector to interrogate your data. Yeah.
And so here, what happens when you use a dynamic workspace is that you just get one source feature class, even though I'm pretty sure in that geodatabase there was more than one. And over here on my destination, I just have one destination feature class. And those of you that have been around FME for a little while will realize that what we've turned on is this merge feature type, which means read everything that you can in through this particular feature type without differentiating them. And over here on the dynamic writer, we are using the dynamic properties at the bottom of the general tab here on the writer. And what that allows us to do is to pick up the schema sources from the geodatabase. So what it's telling us is it's going to build tables that replicate what was in the geodatabase, but it's going to build them all on my Oracle instance.
That's pretty slick, and it really keeps a simplified workspace when you do this. Especially if you say if you got 30 feature types in your canvas, the traditional way you'd see these 30 feature types on your canvas, and now we're just down to one.
That's right. So I'm just going to open up my sample workspace rather than actually run that one and show you how easy it would be to do this to all of our different database formats. So if I open up this workspace, you can see that I actually did the same process writing out to PostGIS. So all I needed to do was know the connection parameters for my PostGIS writer and point it to it. And then when it writes out, it'll write out to a PostGIS database using the geometry model within PostGIS. And I have a couple of settings that I have used here in my default schema definition. And one of the ones that we use quite a bit, especially when we're working with the Esri products, is to remove some of the attributes off the data as it flows into our databases. And these are the kind of specific attributes that you get when you're working with the geodatabase format. So this way I can take them off my incoming features so they don't show up, but the rest of the attributes, even though they're not exposed at all in my workspace, will come through into my PostGIS database. And what's more, it will give them all lowercase attribute names, so because it knows that about PostGIS.
That's really neat. So how do we control what feature types we might read from our sources?
That's a very good point. And in fact, when you create a dynamic workspace, what happens is that the feature types to read becomes a published parameter. So if I prompt and run this workspace, you'll see that it allows me to pick out which feature types I want to read. So it gives me a list of them, and I can click and select the ones I'd like to see. And that way I will be creating those kind of tables on my various destination databases.
That's right.
So I was just going to show you quickly with my SQL Server one here. I have a SQL Server writer, which again, it's going to do the same thing as the PostGIS one, allows me to connect to SQL Server Spatial. And in this case, I have the ability to tell it that I want to have a geography data type. So here I can take my source data and at the same time reproject it into a lat-long coordinate system and write it out with that geography spatial type.
And that's the only coordinate system that the geography one will support in this SQL Server database.
That's right. Yeah. So here I'm doing something to the source data again. I don't know what that source data looks like, but the reader will figure out what coordinate system it's in, and then I can reproject it ready to be in this geography spatial type that SQL Server does so well. And then the last one I wanted to just show you was connecting to Oracle here. And to do Oracle in this example, I had to be just a little bit different because we knew that we wanted our Oracle database to have very specific uppercase attributes and things.
That's right. Oracle does support mixed case, but they do recommend using uppercase. And there's several third-party products that actually depend on that uppercase being found in the table attributes.
Yeah, so I added a couple of transformers in here, that one which would uppercase my feature type name, so I get uppercase tables, and one which changed the case of all my attributes into uppercase. And then because I knew that I wanted my format to look like a table that already exists, say my production database, I actually set it to read the schema source from somewhere else. So instead of reading it from the geodatabase, I got it to read it from an existing Oracle table. Okay,
so how did you get that schema resource in there? Was that something else you had to do to the workspace?
Yeah, so I had to add a workspace resource down here where I put together that Oracle connection and told it which tables I was going to be reading out of this other Oracle database so that my schema would look the same in my new Oracle database.
Right on.
So very powerful. Dynamic workspaces are very powerful, and it's a really great way of taking data that you're not familiar with or don't know too much about and getting it into a new format. So just to continue on with our, where is my thingy? Oh, there it is, of course, thank you. We've got one more poll for you just to find out what databases you are using.
Yeah, so it was interesting, the registration for this, people, we had a question we were asking during the registration, and we've seen a lot of users interested in Postgres. During that, it was definitely the one out front, and that's interesting because over the years, that the popularity of databases has certainly wobbled back and forth and changed. It used to be Oracle really just big time, and now we are seeing a lot more Postgres, PostGIS, even being used by large companies, large corporations. So that would have avoided the open source in the past, right? So
that's right. And perhaps you could, if you're using something that wasn't in the list, perhaps you could ping us and let us know, because we're seeing quite a bit of Netezza out there and some Teradata, and then of course the cloud formats such as Azure and Oracle and those kind. And what's the Oracle cloud called?
The Oracle, yeah, it's Oracle Cloud, and DB2 Cloud is another one that we're starting to play with as well. So. Yeah,
great.
So that's so Stephanie's going to share that. Thank you very much, Stephanie, for throwing that out there for us. And we should see. Oh, did you share that?
I think she shared it. It's in the background on your PC, and so.
No, we're on to the next slide there. We missed it popping up, so
yep.
Apologies. So yeah, as much as the PostGIS was popular during the sign up, it looks like Oracle and SQL Server are at the top there, and Geodatabase obviously is a very, very popular format that we deal with. So thanks for taking the time on that.
Okay, so the next, so we're going to work through the session showing demos in these different formats, and so I've got another Oracle one to show, and then we'll move into SQL Server. But the issue is with these demos that pretty much any of them can be done in any of these formats, right? So we just chose databases on our favorite terms, so to speak, and but basically when you get the workspaces, you could modify them to work with a different format.
Yeah, that's great.
Yeah. So the next thing I was going to talk about was updating and deleting, because it's all very well to get your data into your database, but almost right away something comes along that is going to put your database out of sync, and so you're going to need to bring it up to date. And in fact, what happened here was I had some traffic light information that went into my database, and right away someone ran down the hall with a CAD file saying, you know, we've got a whole bunch of burnt out traffic lights in Vancouver, you need to get your database up to date. And so what they sent me was an AutoCAD file which I can read, and I'm going to make use of a couple of new transformers that were introduced in FME 2014, 14 I think, that we've put up there for helping to make database work a little bit easier. So these are great for simple updates and deletes, and what they are writer transformers that actually do writing for us. So here I've got some AutoCAD data that's got some updates to it, and what I'm going to do is change the status of one of the fields, so that I'm going to change my status on that AutoCAD file to burned out. And then the transformer itself is quite simple to use. You give it the format that you're interested in, you give it the table that you want to update with, and then you tell it which column you want to match on. Now in my case, my AutoCAD data has got some text in it that says what the name of the traffic signal is, and I can compare it to my text string. So if I had another field here, it would allow me to, it's actually going out to the database at this point, figuring out what fields are in the database, and then do I want to match on any of these. And then that allows me to pick from my workspace some other attribute that I might be wanting to match on. So this is how I figure out what's going to tell me which features to update, and then the bottom section here is going to tell me what columns I actually want to update on. So here I'm going to update the status column in the database with the value of the status coming from my source field. And so that's how this transformer works. And similarly, I can do the same thing with one called the database deleter transformer, which again asks for the format because it's actually a writer transformer, finds out the table that you want to work with, and then again just what do you want to match on. And so in this case, when it finds a traffic signal that has the text van FT151, it will delete that particular record or records. Okay, so that's the very basic updating scenario that you can use when you're working with fairly simple updates like this, where you actually know what the update records are that are coming into the database. There's a whole lot of other options that you can make use of, and my workspace fairly quickly got very complicated when you are working with data that you might not know what's different about it. So here I'm actually going to read my existing database feature class, compare it to the data that's coming in, and use a change detector to transformer to figure out what the differences are. And the trick with using the change detector is really understanding what the outputs are, what's coming out of these different output ports. So in my case, it tells me that I've got some deletes coming out. Should I be brave enough and try and run this? And we'll show you what the feature counts look like, actually.
Yeah.
And then that makes it a little bit easier to understand, actually. So let's disable this lot, and we'll run this, and we'll take a look here.
Brave.
Brave, yes. It's always brave
Live
running
demos.
anything live. Especially
Well,
in
you
these
know,
webinars.
it was working. It's all good, fine.
Yeah.
There's a worthy mention on the AIR connecting to the Oracle database. We try uppercase and lowercase, so if we try one way, we'll try again. So you guys can always ignore that message as long as you have a successful connection, that is.
Yeah. So let me go back to my workspace, because it's very important in these kind of cases to look at the feature counts. It looks like I have changed my, of course I have to do this.
Oh, I see. That means you got to run it again?
I might have to just run it again. Sorry about that. Basically what I wanted to show you was how the feature counts indicate what's going on with your data. So here I'm using change detection. So I have a table with a set of features in it and some changes that are, have come in. And I want to know, is the change detector telling me what these features are? So you can see my deleted count is actually really high. But in fact, those aren't features that need to be deleted. What they are features that weren't included in the revised file. So it's very important to understand what your data looks like. Here I've got added, so I've got 4 features that have come out here. These really are new features that need to be inserted. And so in this particular case, we have to define the attributes on the features so when they get to the database, they've got good values on them. And then the third set was this unchanged set. Well, although they're unchanged because they match the database records, these were the ones that we actually wanted to change. And so these are the ones that are going to be updated. So here I can set the status to this burned out value and tell it that the operation that I want the database writer to perform is an update operation. And so when this feature gets to the writer, it will update it. Similarly over here, I've got this one where my status is going to be set to working and my FMEDB operation is going to be set to insert. So I just also included in this workspace when you get sent it a couple of other options to using the change detector, and one of them is to use a feature merger and another one is to use a feature reader, so that you have 3 different ways here of trying to figure out what's different between your various data. And then a hint that sometimes the CRC calculator can be useful for figuring out changes between existing features and incoming features. Okay, and then it's just the last note on working with the Oracle data. We included a screenshot here showing what the data looks like if you were looking at it with GeoMedia, because GeoMedia is something that people who are working with Oracle often are making use of. And so, Steve, did you have to do anything fancy to get this GeoMedia access working?
Yeah, not really. It's just a matter of loading the data into the Oracle database and then making use of the database utilities that comes with GeoMedia Professional to add in the metadata for the new features that we added. That was it. And then we have read-write access to that new data that we created with FME within GeoMedia.
Great. And so you can see how easy it is to get that data into something like a viewing platform like GeoMedia. Okay, so then our next demo, we're going to move on to SQL Server. And we were going to take that dynamic workspace that we've got and enhance the value of it by adding in the ability to do schema mapping as we bring those features over. And this is something that happens quite often when you're working with databases. You might be bringing in data from some generalized format, but they want you to put it into a schema with very fixed attribute values or attribute names and feature class names, table names, that kind of stuff. So a way of doing that is to make use of this schema mapping capability that's available in FME. So let me just take a look at how that works. Let me open up my schema mapping transformation. Now, the whole point about schema mapping is that you need something to tell it what you're going to do, map the schema around. So in my my miscellaneous folder, I have a couple of CSV files. This one, I forgot to open these out, didn't I?
Yeah.
I told you that I was going to do that.
There you go. Yeah. So this is just a CSV file, so it doesn't retain its formatting as it would if it was an Excel file. So here we go. We're just kind of expanding these columns so everybody can see them better in the audience.
Okay. So what I've done here is, as my data is coming into my workspace, I need to change the names of the attributes as they go across. So, for instance, in my neighborhood feature class, I have a source attribute that just is called pop2001. And the DBA has said that if it goes into the neighborhood polygons feature class, it's got to go in as population_2001. And this is a fairly common problem, that they've defined the tables already and they've got a pretty fixed format, and the attributes have to be mapped from your source into that format. So what we've done here is, usually if you're working in one of these kind of projects, you've probably got Excel spreadsheets or CSV files out there that you're starting to set up with that kind of mapping in them. And here we're doing that mapping right from within the CSV file, so that you don't have to use transformers in your workspace that would do this for you. And remember what that workspace transformer is called?
The value mapper.
That's right,
Yeah.
the attribute value mapper.
Yeah.
And the problem with using transformers within the workspace is then when you've got a new mapping to do, or you have to add a new table into your sheet here, you have to go into the workspace and manually change the transformers. And the beauty of schema mapping is that we can do it all outside the workspace, and it all happens at runtime.
Yeah, and keep in mind, this is a very simple example that we're showing here with the schema mapper, but some of these mapping files can get quite large depending on the number of features you're working with and the complicated attributes that could be happening, and pick lists and that sort of stuff. So a lot of great stuff that can go on in there.
That's right. And so we have an example here of inside my schema mapper, I'm getting it actually to do three things. I'm asking it to filter the features, so only do this action when the source feature matches some attribute that I've told it. And then I want to map attributes, and I also want to map feature types or table names. So let's have a look what happens when I click on this create an attribute map. So here's my table underneath, so it's read in my CSV file with all its nice columns in it. And basically I'm telling it that I want to take the source attribute from the source attribute column and move it into this, rename it with this destination attribute name. And similarly, if I look at one of the other mappings, the map feature types, you can see here I'm taking the source feature neighborhoods and mapping it into the destination feature type, make that a little bit bigger, neighborhood polygons. So this is all a way of getting my incoming data into the kind of fixed schema that my database requires. Now, I believe Stephanie has spread out a good FMEpedia article on using the schema mapper that has just been rewritten by one of the pro services people. And so if you're interested in using it, it's a very powerful transformer.
It sure is. And Mark has just chatted a couple of links to the schema mapper and dynamic workflows. So those two are great links for you to help. I think so. Stephanie may be off the hook for sharing that.
Okay.
Yeah.
Okay. So that's the start of my mapping process. So here I'm mapping the attributes and the table names, and then I'm adding a bit of value to them just by time stamping and attribute creating. And then in this case, because I'm writing to SQL Server, it's a really good idea to use a geometry validator, because SQL Server, in particular the geography model, is quite picky about its features.
Sure is.
And so here I'm going to do a geometry validator just to check for my 2D intersections, just in case there's any of those in my data. And that will repair them before they get to my my destination writer.
And key point, especially working with SQL Server there, is it does have its own validation that it can do on its geometry. And we have seen geometry get loaded into SQL Server, but probably more on the geometry data type versus the geography. So just something there that you can check out too. And can make valid, I think it's called, the procedure.
That's right. And again, there's a very good FMEpedia article on how to do that as well. So the last thing I was going to show in this workspace is that I've set up my attributes and things so that they're in the right order for how my schema wants to be, but I don't actually have those tables built yet. So I am going to force the building of those tables based on a schema that's also coming from a CSV document. So here I have another CSV document that actually lays out what these tables are going to look like. So here is my address points table, and you can see these are my attribute names, and this is the data type that I'm going to be using in them. So FME integers or varchars or even a date field here. And I also tell it that this is going to be a point table.
What's that order column on the far right there?
Well, as I was putting this into my spreadsheet, I realized that I didn't want the attributes in this order in my table, so I can specify the order by saying, you know, this is number 1, this is column number 2, column number 3, and so on. And so when I run the workspace, it will pick up that schema definition from my my schema source.
That must be another workspace resource, is it?
That's right, and it's been added into my workspace as a workspace resource. And what it is a schema from table reader. And the schema from table reader allows me to say what columns each of these things are. So it's going to pick up the feature type from the feature type column, and so on and so forth.
Fantastic.
So let's have a look. Oh, I didn't start up my Microsoft SQL Manager, but we could see.
So everybody get ready. We're going to do a little Q&A here, see if there's any questions popping around. So please feel free to Mark and Ken are looking at some questions there for us, and hopefully they'll provide us some there after we finish this demo here.
Yep. So here's my tables, my address points, so you can see the columns came in the way I wanted them. They came in the order that I wanted, and they've been given the varchar values that I had set up in my spreadsheet.
So quick raise of hands. How many people are using either the schema map or the dynamic workspaces already now out of the audience? That's just to see if anybody's really paying attention to us too. Yeah. Oh, look at that! It's there is quite a few people making use of it. Great.
That's right. Cool. It's very powerful stuff, and again, you'll get the workspaces, which will help to explain it at all.
Yeah.
So, do we have any interesting questions, or should we just plow on?
Well, we're a little bit behind where we would have been on our timings yesterday. What do you think, Mark?
Somebody asked if the data transformer will update column values to true Oracle nulls, and in 2014 we did a lot of work throughout the entire product, making sure that we handle nulls properly. And so, yes, we will. If you are using FME 2014 or higher, you will get proper Oracle nulls in your databases.
Yeah, it's a great addition. We should have been doing nulls for a while, but 2014 is the first real version that could do it.
Yep.
Quick one. Can you create those GeoMedia metadata tables within FME at all, or you have to use those database utilities?
No, there is. That's a good point, Ken, and I actually was going to mention that. There is a package from Intergraph called GOOM, Geospatial Oracle Object Model, and it's a package of procedures you can install in your Oracle database, and we actually have an existing workspace that I've put together that can actually do that stuff automated. So there's a couple little tricks around it, but it works pretty slick. So if anybody's interested in that, let us know, and we can share that with you.
Great. So we're going to just keep plowing along here because we've got lots of stuff to show still. And
yeah. So Robin's talking a lot slower than our timings, I think, is what's going on.
Well, people always say we talk too fast, so we're trying to talk slow. So I'm just going to do one more SQL Server demo, and then I'm handing it over to Steve to look at some PostGIS stuff. So we were just going to show that how to handle multiple geometry in FME 2014, because it did actually change a little bit. A couple of the core transformers changed the way they worked. And so, of course, many of the formats do handle multiple geometry, or multiple spatial columns is, I suppose, what you really call it. And so the way FME deals with that is that we can read and write from multiple spatial columns in PostGIS, in Oracle and SQL Server. And of course, Small World handles them natively, so we've always managed to deal with the multiple spatial columns there. With PostGIS, if you issue a select statement using, say, a SQL creator to get at your data, you can extract the spatial columns out that way. But we don't do it on the readers and the writers. So the way it is done on the other formats is that we have this handle multiple spatial columns setting on a parameter, and you need to set that to yes to say that my data is going to be a table that handles multiple columns. We also don't build these tables, so one of the ways to build them is to build them yourself using the SQL statement to execute before translation. And Steve's going to show some more examples of using that particular option on a writer. But here I am building using a create table statement to build my table with two spatial columns in it, one in the geography model and one in the geometry model. And you've noticed I have given them different names. So in my case, I decided to call them points and polygons. We could have called them geog and geom or anything, but it's very important to know what the names of the columns are, because that's how you are going to name the geometries of your features as they pass through the workspace. So here I have my features coming in, and they are polygons, so I give them a geometry name of polygon so that they match up with that destination table. I'm also going to spin off a bunch of features and create points out of them, and here I'm going to set the geometry to points so that we know which column it's going to go into. Also, because they're going into that geography model, I do have to manually reproject them. And so I've added a reprojector in here. But the trick to working with multiple geometries is that we have to aggregate the two geometries back together again based on some ID field. So in my case, this is parks data, and I had a park ID field, so I could group them back together again. And I need to keep my input attributes, and the options are not quite as easy to find in the new aggregator, but basically it's a mode of assemble to one level and an aggregate type of multiple geometries.
And this has changed in 2014, so be aware if you have used multiple geometries in the past, just have make note of these settings here that we're using.
That's right. And then we have a new transformer here that says it's a multiple geometry setter, and it's basically you set it on each feature to say these features are participating in a multiple geometry. And so then when I run this workspace, it will drop any existing table if it exists, create me a brand new table, and load it up with data. And if I have a look using SQL Server, it's actually quite fun. You can look at it in here. We can see the columns, so we can see that we've got points and we've got polygons. And when I select the data from it, down here in my SQL Management Studio, I actually can look at the spatial results, and I can see that my points, they're pretty dim in here, but you can see that they are definitely lat-long coordinate systems. And then I can look at my polygons, and I can see that it's a projected coordinate system. So that's how I know I've got multi-geometry in here. Okay, and so for reading multi-geometry, the same thing. As you read it, you need to deaggregate them all so that you can look at the different parts of it. And just as a final note on SQL Server, here's a screenshot showing what your SQL Server data might look like if you looked at it in ArcMap. And did we have to do anything special to get it into ArcMap? Not really. These days, all it needs is a unique integer key field, and even that ArcMap will build on the fly if you don't have one, and you can just drag and drop your tables into ArcMap, customize the colors, and show the data. Yeah. So it's all very powerful.
So quick raise of hands, how many people are making use of multiple geometries now?
Great.
So just, yeah, there's quite a few out there doing that as well. Nice. All right, so we're going to switch presenters now. I think Stephanie can bounce us over to my screen, and we'll see in a moment, hopefully, that come to life. There we go. And I will set up my screen sharing to show main screen, I think. Are you seeing the right screen? All right. Yep. So I presume everybody's seeing my workspace there now?
If not, we'll get some screeches coming through in a minute.
So we've got, yeah, so that's a good crowd. Sorry, go ahead, Steph.
Yep, there we go. Excellent.
Yep. Okay. All right, so I've got a couple of workspaces.
Just saying, yeah, we can see your screen.
Awesome, thanks. So we got a couple of workspaces we're going to run through here. The first one we're going to be looking at is the PostGIS and working with foreign keys. So I've got a couple of workspaces that I'm not going to bother showing now because of our timing, but essentially what I have is one that's going to create a table, and it's a reference table. Basically, it's going to look at the unique values in an existing zones table, and it's going to create that table, and then we've created a foreign key on that table to point to the parent table zones. So if we look at the database, what we're going to see is a couple of tables down here. So we got the zone. Oops, we've lost connection. Yes, and we've got the zones and the zone cat, and so that's interesting. And essentially, those are the two tables we're using in this demo. So I'm just going to switch back to my workspace. The first example here, anytime you load data into your database, you're gonna, and you are dealing with foreign constraints. The values in the table that are referenced, they need to exist in that child table. So here we go. We run this, and what you'll see is for errors in this situation, and so this is the record I'm trying to load in. It's got a zone recreation of creator. If we go back to PostGIS admin, we can see that in our table here, if I view that data, I don't have that value there. Okay, so we're not seeing that. And so in FME, what happens is we get this error message in our log that it violates the foreign key constraint that we have set up on that parent table. So one way we can do that is to actually create that new reference key with FME, and that's what we're doing here in this example. Basically, I'm reading that same data I was reading here. I'm determining, does it exist, doesn't, and then I test to see if there's any matching records. We're going to spit it out, and we're going to actually write it out to a Postgres writer into that zone cat table. So this is kind of an administrative kind of side of things, but it gets away from using your database DBA. A couple things, so we'll just run that, and now we'll get a record in there, and we can see that's run. It's put one more record in there. If I come back to PostGIS and refresh this, we got our new record in there. And we go back to FME, and we'll disable that, and I'm going to rerun that first part that failed again. So running that now, and we'll get that record inserted in there successfully. So basically all I did there was add in a new reference key in that zone category table so that I can insert my new data. So that's one way around constraints. It's to ensure that your data, your constraining data exists. There is another way to do all this, and in this example here, essentially what I'm doing is making use of the SQL statement to execute. Very powerful, these things. I mean, it takes all kinds of SQL, PLSQL kind of stuff. But basically what I'm doing here in PostGIS, there's not a disable constraint. There's a drop constraint. And I'm dropping that original constraint only to recreate it after I run my workspace. It will get recreated, added back on in the same way. But note, I have this not valid. And basically what that means is anything that exists in the table will not get validated, and that means you may have some key values there that aren't referenced properly, and that's some homework to do after the fact, which would be running again something like this up here. So hopefully everybody gets the gist of that, because we are talking about a technical database webinar here. So now if I run this, and we'll note that when I run this here feature is actually trying to load a new category called new category. And if I, whoops, I want to just run this. If I run that, it's going to go off and it's going to insert that one record into there. And that's because it's taken away that constraint, it's loaded the data, we've re-added the constraint so that maybe other third-party applications using a different interface wouldn't be able to load any data. If it updated any records, it would still check that it's a valid constraint, reference key available. So if we go back to PostGIS admin, I don't think I have an SQL to look at that, so I'll skip that. But essentially, trust me, I've inserted that into the parent table as a new category. So it doesn't exist in the reference table.
Is that SQL that you're executing there, is that PostGIS SQL, like would the same statements work on Oracle? Or
yeah, there's a bit of different syntax in some of this. So you just got to be suave in the SQL that you're working with for that. I think in Oracle this would be no validate or something
Yeah, so basically these SQL statements are being passed right back through to the database management tool that you're working with, or that writer is set up for. And so you have to make sure that it's valid SQL in the database that you're working with.
That's right. So.
Yeah. Cool.
All right, so we've got that one. Now, what's our next slide? Oops, I got to go back to here.
You're the slideshow.
I'm the slideshow guy, and I haven't actually showed it, so let me just get rid of this.
It's not on this screen.
No, I know. I'll get it down there in a sec. And here we are, and I'll present. Sorry about this, guys. So everybody can see that now. So the next, so that was the constraints that we were working on, and now we're going to move to the blob fields and PostGIS raster writer. So we're going to skip back to, let's go here and see what I can show you. Is it this one? Let's see it. No. Yeah. So here we have one where we're loading, we've loaded rasters very easily. That's loading some JPEGs into our raster, our PostGIS database. But what I'm going to show here is writing the blobs. This is what we needed to do here. We've got our...
There's actually a couple of ways of writing rasters, right?
Yeah, that's right.
You can either...
This one here uses the raster format. It uses the raster, the PostGIS raster writer.
Yeah, so that's new in PostGIS 2.0.
Yeah.
And new in 2014.
2014, I think. Yeah.
So that's actually writing rasters as PostGIS would handle them. But one of the older ways of writing rasters was to write them into a blob field on the end of your sort of feature class.
That's right. And so I'm just fluffing around here on the screen here, but you can see down here we've got file contents, and that's going to be throwing it into a blob into the raster or into the PostGIS database. So we're reading. What we're doing is reading the data. We're getting a location of a file. Okay, so this is the location on my local system of this file that we're going to load into that blob. And basically, we create that attribute. We concatenate it together. It's a binary that we're creating.
Yeah, but now that's an interesting transformer, that attribute file reader, because that's actually it's a transformer that's a reader transformer, right?
That's right. It actually goes out and reads the destinations that you've given, the files that you've given in the destination attribute. And so that file contents is being mapped over here, and in the database, we will see in a moment, if we run this, it will load it into our system. And we can see there it's loaded 8 features. If we go back to PostGIS and we look at our fire halls, which aren't there because we just created them, and there they are. They've appeared. You can see down here we've got that same format.
And so that byte A, that means that that's a binary field?
Yes, it looks something look like this when we look at it in here. Binary data. So.
Oh, okay. So in some of the other database formats, it might be called something differently, but in all cases, we handle those blob elements.
That's right. So in that case, that's how we can do it, to write to a blob format. But what about if we want to read back out? And it's a little bit more, a couple more transformers, but essentially not much different. And again, we'll just read these out to the data inspector, and we'll see our. Whoops, I think where's my data inspector? So we've got these little. I'll zoom in a little bit, but here's the features they've come in, and we can see here we've got these little pictures georeferenced on our map with these little images from those, and these are pictures of our Vancouver data, our Firehall data set. So we've got another fun little one that we're doing with this one as well that we'll show in a second, but that's another way to get your data out that's been stored in a blob. And just a note on storing rasters in your database. We see people doing that. It's definitely recommended in situations where you got not a ton of raster data that you're dealing with, or JPEGs in this case. But if you're really looking at high volume, a low number of rasters and high volume data, yeah, the database is not a bad choice. But if you're dealing with a lot of raster data, It's really, people are still kind of keeping those as flat files and maybe using pointers in your raster tables in your database that you can pull that information off the flat file system. Okay, so last but not least, we'll disable that. We're going to read some more raster data here and just pull out those into our data inspector. And this is reading the the PostGIS raster format. So this is not the binary, it's the raster. So we'll go over to our, and there we go. We've got in this area, if we were to look at this, we've got 8 records or 9 records that come in here. We can scan through all those. And they're not georeferenced, and that's why we're seeing them look like this. They're just images stored in your database. Had they been georeferenced properly and put into your database, then these would be also out on a map. All right, so we're done with that workspace.
Well, there's another third way of holding rasters into your into a database, and that's a method of putting in a footprint bounding box and then using a link to a file location. So sort of one step down from the whole idea of doing the blob saving, right? So we could have calculated the bounding box or the footprint of these rasters and then just put a link into the C drive showing where those rasters were. And we could have done that as a third method. And I know that's kind of the way the ArcGIS mosaic data sets work, is that they are pointers to files sitting on disk rather than actually loading them into your database.
Yeah, that's right.
Because orthophotos take up a lot of space.
Absolutely. All right, so the next demo, we're just going to do a fun one with PostGIS. We've got that raster data that we just loaded in there, and now we're going to pull it out and view it in KML. So Robin and I were pretty happy getting this one together. So we've got our PostGIS data, and we've got our PostGIS JPEG, so we've got our raster reader here, and we have our normal PostGIS reader. So basically we just go through and we're extracting different properties that we need to from the raster, and then we're merging those with the data that's coming out of Firehall's in this case, and then we're just writing it out, doing a KML property setter, and creating an HTML content that's going to populate into our balloon when we show it in Google Earth. So if we just run that, and I think I'm writing it to output, so we'll see that that's completed successfully underneath here. It's written 11 features, 11 Firehalls. Yeah, that's live right now. And then we'll just open up Google Earth.
Steve was much braver. He actually decided to run his workspaces.
Yeah, well, there's nothing like a live demo that doesn't have something that breaks in it, right?
Exactly. But this was kind of a cool example, because here we took raster data and vector data of a bunch of points and converted it all to come out to KML. And now if you click on a KML point, not only do you get a photograph of the Firehall, but you get some information about where it is.
Yeah.
And in fact, that one there is just around the corner from where Mark Stokes lives. So you'll even be able to verify that that's the right picture for the right Firehall.
Well, there you go.
Yeah. But, and some of them ended up with 2 photos, because I think one of them over here was
this one here.
There was,
they've got 2 Firehalls here.
But in fact, the photos, one is the photo of the Firehall and one is the photo of the library next door. But anyway, interesting stuff you can do with your data, pulling it out of a database. And I think what we wanted to show was how you could view any of this database data in any of these common viewing applications.
Mm-hmm.
So we've seen how to look at it in GeoMedia. We could have done that with our SQL Server, because GeoMedia, of course, works with SQL Server. We could have done it with ArcMap. So ArcMap, of course, will work with PostGIS just the same as it works with Oracle Spatial or SQL Server Spatial. So, and KML, of course, you can pop anything over into KML. So the whole point was to just show you the flexibility of FME and then working with that data in those different formats.
Yeah, that's right. Yeah, and if you get once you get the links, we're going to share out from these demos here. There's an Easter egg in one of mine that I didn't talk about because of time. But you know, working with sequences and how you can pull values out of there, so you can review the workspace there on the PostGIS and see that information.
Yeah.
Okay, so it's getting near to wrap-up time. We got what, about 6 minutes to go, I guess.
Great. And so we hope that you've managed to come out of this with something. We wanted to show you how dynamic workspaces were incredibly powerful ways of getting data into your databases, and then when you combine it with the schema mapper, working with predefined schemas, And as Mark sent out a couple of links, we will also possibly get those links into a slide so that when you get the slide set, you'll be able to find them, to articles that we've put together to show how easy it is to work with those things.
Yeah, and I stress, if you haven't started playing with Dynamic Workspace as a schema mapper, and you're working with large volumes of feature types and moving data from different sources in, I really, really, really recommend you dive into it. It is a bit to get into, but once you get into it, you'll never look back.
Yeah. And then updating and deleting, we talked about that, some of the options that are available, fairly simple updating and deleting using the new updating and deleting transformers, and then more complex updating and deleting and inserting with the change detector and format attributes. The reason why I didn't go into it in a huge amount of detail is that in FME 2015, which will be available in a beta fairly soon, we've done some fantastic work around that area on the database writers, and so it will have changed a bit coming into 2015, and that whole notion of having to set things in half a dozen places to make your updating work will have disappeared, and we're going to be adding in the ability to save your connection information in a file so that when you change your password, you don't have to go in and fix all your workspaces. You can just fix it once in one particular place, and it will ripple through everywhere. And we're going to do this writer mode stuff. So 2015, again, some exciting enhancements for databases.
For sure, yeah.
We talked a bit about multiple geometry, just how to do that in across coordinate systems, and the new changes to the aggregator that make it a little bit harder to find that multiple geometry support. Steve talked about working with constraints and foreign keys, and how that basically works the same for the other formats. So when you get those workspaces, if that's something you're interested in, you can modify it to your own workspaces, to your own databases. And then the last little bit about loading rasters. Each of the formats, except for SQL Server, handles rasters, so you could have done the same trickery with Oracle, with the Oracle GeoRaster writer as we did with the PostGIS raster writer. It works the same way. It loads it into Oracle's spatial raster format. Just like
GeoRaster.
Yeah.
Yep.
And of course with SQL you could have loaded it into a blob just as we showed there also. Okay, and then of course that it was easy to read all of these formats from the third-party tools.
Yeah. Okay, so yeah, we've got a couple of things coming up here. September 4th, we're doing some business information conversion. And it's an analysis workshop, so that's going to be on the story of the I-35 here in, I guess, south of us in Washington State, bridge collapse. So please join us for that. And then September 24th, we've got a MicroStation centered focused webinar coming up on how to integrate CAD with GIS. And continuing at SAFE, we do still do a lot of CAD to GIS and GIS to CAD. That's really, really a big one.
And I think the value for this one is that it's a MicroStation talk. Often our talks are AutoCAD, so those MicroStation users, you'll get some good stuff out of that one.
Yeah. Okay, and then some free training. So if you are new, and there was a quarter of you that were very, very new to FME, please join us. Dive into the different free training we do. If you're starting out, FME Desktop on the 16th and 17th of next month is a great place to go. We also have on August 27th, we'll be doing an FME and Esri focused webinar or training, and that's what, one morning, 4 hours? That's tomorrow, right?
Yep. I'm doing it. That's
yeah,
right.
and I'm QAing. Oh, wow. I forgot about that.
So the Robin and Steve show starts up again tomorrow morning at 8:30, doing an advanced.
It's really the Robin
training
show.
On Esri, the product. And then in October, the date hasn't been announced yet, but in October, Steve will be doing a database training course, so an advanced database.
Am I?
Yeah, possibly. Well, it'll be you and me again, but
yeah.
You're leading that one. Possibly with SQL Server, but maybe with PostGIS, depending on how those materials get put together.
Yeah, and don't forget September 23rd, 24th, FME Server. If you use FME Server or you have people in your team that are new to using FME Server, get them to get on the course there on the 23rd, 24th, 2 mornings, 4 hours. That's a really good one to look at. We don't do those ones as often. Okay, so Q&A. Let's bring Mark and Ken, who have been patiently waiting to get on here for a couple minutes airtime. We're just about out of time, but we'll extend over the hour for a bit of Q&A. Guys, you there? Dun, dun, dun.
I can hear somebody.
I don't hear Ken anymore.
Okay, so they had a lot of questions.
Yep.
They've been pretty busy throughout the time.
I do have
okay,
one.
Mark.
Oh, sorry.
Hey, Mark, go ahead.
Yeah, there were a lot of questions. I'm not sure whether there were too many that were really relevant to everybody. There was somebody that was disagreeing with your approach of disabling constraints there. They said in a big database that wouldn't be the best approach. And so I think if you don't disable the database constraints, I think you did give another option.
Yes, absolutely. And I meant to actually mention that is more in an area of bulk loading your data. Quite often people are doing bulk loads in those cases, and they have a database model that's already been designed. And so, yeah, that's a very good point. It's actually, I totally agree with it. For just individual data loading, I wouldn't recommend that either. But certainly for bulk loading and building a system up, or maybe a staging database, yeah.
Yeah, and so there are ways of ordering the feature writing so that they write the the parent tables before they write the child tables, and you can do that sort of thing by ordering your writers, or by even ordering your features, throwing a sort key on them and then sorting them in a particular order. There's tricky ways to get around that particular problem.
That's right, yeah. No, that's a good one to bring up, Mark. Thank you for clarifying that. Great, Ken, you got anything?
I was actually going to ask the same question, but because that was a good one, I thought. The other one that came up, a couple of people asked about speeding up table joins. Someone asked in the context of SQL Server. Someone asked in the context of Oracle. Any tips there?
Well, definitely. Attribute indexes make a huge difference. Working with the databases, any of that work that you're trying to do, putting an attribute index on the fields that you're going to be work with, and in any production database they would already be there. But sometimes people who have come from a spatial area don't think about that kind of thing, and attribute indexes can make a huge difference.
Yeah.
Otherwise, I suppose joining on single keys rather than multiple keys is probably faster. And I believe on one of them, there's a way you can order it so that it'll be faster. You can tell it which features are coming in first. I can't remember which of the transformers it allows you to do that, but
yeah,
that can also help to be ordering the features so that they go into the transformer in the right order.
Yeah, and then the other thing too is, we're dealing with databases here, and they're the best at joining tables and creating views on those joins more permanently in the database. And with FME, you could, in theory, if you had the right permissions, you could, in theory, create a view up front that creates it in the database, and then use FME to read that view and then drop that view, and that would be the SQL statements to execute before and after. Now that's crossing into the DBA territory, but some environments, some businesses allow you to do some of that stuff. You could have a temporary view that has access to the tables you need, and that would definitely be something to consider for performance. But like I said, DBAs are quite controlling and don't often allow that kind of behavior to happen. Because you got to remember, if you're pulling all your data back from your database and joining it inside of FME, you're going to get hit with that, especially if you're only needing a subset of data from one table to do your comparisons. We also do some caching with the joiner. Does the caching, or is it the?
Yeah, it's the joiner that does some caching, or allows for some caching to go on.
Yeah, so that's another thing to consider, is the joiner transformer. Yeah, good question.
Okay, so I think that probably wraps it up. Where it's after 9 o'clock now. Yep. There's one more slide there just with some email addresses on it. So if anyone has any questions, or you think of something that you didn't ask today and want an answer to, feel free to email us either at info@safe.com for kind of product information or pricing information, and support@safe.com for technical questions. And I think looks like people have been sending out the links to the Esri course, which is happening tomorrow, and the online course schedule, which has those other courses in it.
Yeah.
So lots of follow-up material around. I hope you got something out of this morning. And
yeah, thank you very much.
Thanks for attending, and we'll see you the next time we have one of these things.
Thank you.